Welcome to another video on this channel, Code with Vinay. This is going to be what I call a food for thought video, meaning that I'll give you something to ponder and act upon. The idea is that one learns programming by doing and not by viewing. Depending on the responses and reactions received, I'll decide whether to make a detailed video on this in the future. So, do not forget to comment in case you want me to come up with a detailed video on this topic. In number theory, a factorion in a given number base b is a natural number that represents the sum of factorial of its digits. For example, in base 10, 145 is a factorion because 1 factorial plus 4 factorial plus 5 factorial, that is 1 plus 24 plus 120 is equal to 145. The objective is to write a Java program to find the number of factorions in the entire range of integers, that is from 1 to integer.max value. Factorions in base 10 are also known as special numbers, and while it may look simple with a straightforward logic, the reality is quite different. So now let us have a look at the usual approach of solving this problem, and the program is right in front of you on the screen. I have broken it down into different functions so that we can discuss it easily one by one, and you can convince yourself that the logic is what it seems to do. So the first function which I've made over here is the function get factorial, which computes the factorial of any number. So we have taken a variable factorial equal to 1, then we are running a loop from 1 to the number, and within the body of the loop we are finding the running product. And that running product is actually the factorial of the number which we are returning at the end. This get factorial function will be used inside the function is factorial, which is returning a boolean true and false because it is trying to find out whether or not the argument is a factorial. So here we are initializing the value sum to 0. Then we are running a loop to extract the digits one by one. So we'll start with the number n. While the value of temp is more than 0, we'll keep on dividing the number by 10. That is, we'll keep on removing the last digit of the number. And then we'll say that temp modulus 10, which is the digit, we'll find the factorial of the digit, and then we'll accumulate it into the variable sum. And then when the loop is over, what we'll do is we'll put an expression. So this expression sum equal to n will return true if the sum is equal to n, otherwise it will return false. And finally, we come to the function get factorion count, which will actually return the count of the total number of factorions. And like I said earlier, the count is initially 0. We have a variable, control variable I, that is running from 1 to integer.max value. Integer.max value is a constant which holds the maximum possible integer value, which is 214748367. And since I don't want to memorize this long value, so what I'm doing, I'm just saying integer.max value. And then we are adding the value 1 to the loop variable each time. And then inside the loop, we have the usual descriptive logic. Is factorion I, that is, if I is a factorion, we'll increment the count by 1. When the loop is over, the variable count will hold the total number of factorions, and finally we return that total number of factorions, which will be printed from inside the main function. So this is the usual logic of this program. Now let us run the program and see the most interesting part of this. So there we start. So the program starts running, and you'll see that it is still running, and the usual thought process is that it might run into an infinite loop. But as you can see, the program is still running and running and running. Now your task is to debug this program so that it gives the correct output in reasonable amount of time. In order to save your time, I'm providing the source code in the description below. That's all for now, and do let me know if you're able to resolve the problem in the comments below.